All right, guys. Before we get started, are there any questions over the homework? Questions over 7-1. 7-1 was kind of nice. It is our direct and inverse variations. Really, inverse variation, the main reason it shows up in this chapter is because, well, we have a number over a variable. It's a rational expression, rational equation. And that's the last time it's going to show up in chapter 7. Or inverse variation anyways. So, Now, rational expressions is a fraction whose numerator and denominator are non-zero polynomials. We have an x on top or bottom. Now, the domain, the x values, the values that we can plug into the expression do have some exceptions, some restrictions to them. The denominator, the bottom of it cannot be 0. We cannot divide by 0. So any value of x that would make the bottom, the denominator, be 0 is a restriction. It has to be removed. We cannot have those values. We can't have that division of 0, which is nothing new. We've had that. We can't divide by 0. We've been told that for years. We can't divide by 0. Now, it is also considered in simplified form when the numerator, the top, and the bottom do not have anything in common other than 1 or -1. 1 and -1 are the only common factors. So, like this here, AC over BC. Since C is in common on top and bottom, we simplify it out. And it becomes A over B. 15 over 65. They have a common factor of 5 on top and bottom. We reduce it out, giving us 3/13. Or, in the last one here, we have x plus 3 and x plus 3 in common on top and bottom. Those reduce, they cancel out, leaving us with 4 over x plus 3. We kind of see that there, yes? Okay, so let's look at an example of this. So this first one here, 4 over x times x plus 2. What is in common on top and bottom? So it would be very tempting to want to factor the 2 with the 4 and 2, yes? But the 2 on bottom, that x plus 2, is one expression with our plus and minus. When we have x plus 2, that is one term. That's one expression. They're stuck. Now, if let's say it was 2x, 2 times x, that's multiplication. We can simplify the 4 and 2 as a multiplication. So, wait, is there anything in common on top and bottom? No, this is already, it is already simplified. There's nothing we can do to it. Because there is nothing in common on top and bottom. It is as simplified as it gets. Thought I'd start off with one that was simplified. Now let's look at the next one. We have 2 times x plus 1 over x plus 1 times x plus 3. So what's in common? Well, the x plus 1 and, because the whole expression is in common on top and bottom. X plus 1 and x plus 1 are the same. So the numerator, the only thing left is 2. The denominator's only thing left is x plus 3. Now, there's a reason why, or behind what we can do here, why we can cancel this out. And this is going to be, we're going to come back to this a little bit later with multiplication. But when we multiply two fractions, focus up here, up here. When we multiply two fractions, we multiply numerator with numerator, denominator with denominator, top and with top, bottom with bottom, yes? So really 2 times x plus 1, I can say is 2 and x plus 1. Because 2 times x plus 1 would be our 2 times x plus 1, yes? We're comfortable with saying that. Same thing with the denominator. Because x plus 3 times our x plus 1, we can put 1 with x plus 3 and 1 with x plus 1. Now there's a specific reason I set it up this way. Is because one of our two fractions here, rational expressions, is x plus 1 divided by x plus 1. What do we get when we divide by itself? Not quite. Anything divided by itself is So the second expression is just what? This is why we can do it with multiplication, because I can pull it back apart, put what's in common over itself. Anything divided by itself is 1. So that reduces, really leaving me with 2 over x plus 3 times 1, which is 2 over x plus 3. That's why that works, why we can just cross it out with multiplication, but with addition and subtraction we can't, because that doesn't work with that. We have to have the same denominators, and we add the tops. All right, before we move on, we do have restrictions. All right, guys, up here, up here. So restrictions, because again, we cannot divide by what? 0. So anything that's going to make the bottom of the fraction be 0 is a restriction, and we're not going to really start with, well, we finished it with, but what we started with. So we have 2 places where x can have a denominator of 0. And that's x plus 1 and x plus 3. Because if x plus 1 becomes 0, the entire bottom of the fraction is going to be 0. If x plus 3 becomes 0, it's going to make the whole bottom of the fraction be 0. So with x plus 1, we're going to set it equal to 0 and then solve, which is telling me that if x becomes negative 1, or if x is equal to negative 1, the bottom of the fraction would be 0. So we're saying x cannot be negative 1. Because if x is negative 1, we have a division of 0, and it doesn't work. With our x plus 3, we can solve it by subtracting 3, telling us that if x is negative 3, we have a division of 0, it doesn't work. So out of all the values of x that we could have, negative 1 and negative 3 are restrictions. Does that make sense? So this here, we can list it as 2, or we can say that x cannot be negative 1, comma, negative 3. We can just list them out with commas. Now, some textbooks would disagree with listing the restrictions as both of these, because some say we only need to list the fact that x cannot be negative 1. Because where did we get the negative 1 from? The x plus 1, yes? Well, the x plus 1 simplified out completely. It's gone. So they say any that reduce out that would cause the division of 0, we need to list if they factor out or simplify out completely. So that's why they say the x cannot be negative 1 is included. They say for this here, x is not equal to negative 3. We don't have to list it as a restriction. Because where did we get it from? The x plus 3. It is still a part of our answer, so we don't necessarily have to list it as a restriction, because we can see it's still there that we can't have that. I'm of the opinion, I mean, it's not that hard to find those 2 restrictions. Might as well list them both and say them. Even though that they didn't, negative 3 is restriction still there. You can just say it's not equal to negative 3 or negative 1. So, questions on this here? You ready to look at the next one? Now these are very nice, especially when they're already factored. This one here, is it factored? Well, no. Because we have x squared minus 4x minus 12 on top. On bottom, we have x squared minus 4. So for us to be able to simplify and make sure there are no common factors, we got to factor it first. Now the order in which we factor this, the top or bottom, really doesn't matter. We're going to have to factor both. I always look for whichever one I can see the factors of first, or easier. And with this one here, I would start with the x squared minus 4. Is there a greatest common factor between x squared and 4? Well, no. But x squared minus 4 is our difference of perfect squares. Yes? Because x squared, what times itself is x squared? X and x, what times itself is 4? 2 and 2, and our signs would be plus and minus. X plus 2 times x minus 2. Difference of perfect squares are nice, because as long as we see what the two perfect squares are, first spots, x and x, 2 and 2, to get there. Now, part of the reason I say this and do this is because, again, what are we trying to do? We're trying to see what's in common on top, and so if something's going to reduce, one of the two sets of factors on top has to be either what? X plus 2 or x minus 2, yes? Well, that's going to reduce some of the factors or possible arrangements of the numerator, because I want it to match up with the bottom. Now, the numerator, x squared minus 4x minus 12, there is no greatest common factor between the three terms. But since the third term is negative, our signs are opposite, positive and negative. Factors of x squared are x and x. Okay, factors of 12. 1 and 12, 2 and 6, 3 and 4. 1 and 12, 2 and 6, 3 and 4. One of those has to be 2, yes? Because if we want something to reduce, we want x plus 2 or x minus 2. So let's say I pick 3 and 4. Is anything going to reduce? No, even if I flipped them, we still don't have anything matching up. So that's telling me, even without looking too closely at the factors at the top, well, 2 and 6, I need that 2 to match up with either x plus 2 or x minus 2. So I'm going to probably stick with the 2 and 6 as possible factors. Plus 2 minus 6. Now here it's always good to just check and make sure. X times negative 6, negative 6x. 2 times x is plus 2x, giving us negative 4x. So that is the correct middle term, so these are our factors. Now we do have something in common, our x plus 2 and x plus 2. So we have x minus 6 on top over x minus 2. So I think as we notice here, the key part of being able to simplify these is all going back to factoring again. That's why we spent time going back over factoring, because that's key for this part of the chapter. Questions on how we simplified this here? Restrictions. 2 places where we could have a division of 0. That'd be our x plus 2 and x minus 2. Now with our x plus 2, to see what value of x would make it be 0, we would subtract 2, telling us that if x is negative 2, we have a division of 0, so x cannot be negative 2. With x minus 2, we can add 2 to both sides, telling us that if x is 2, we'd have a division of 0, so x cannot be 2. Luckily, if they are the same number, just different sides, we could say that x cannot be positive or negative 2. Our restriction for this here. For the most part, I'm not going to ask for the restrictions, but again, it is good to look at them and see what they are, because once we start solving these restrictions are going to come back into play. Because if a solution, one of the values of x that we solve and find is a restriction, we can throw it out. Because if it's a restriction, it can't be a solution. Because that means that value, if plugged back into the original problem, will cause a division of 0. Can't have a division of 0. So we can throw it out. We don't even have to check it. We can immediately throw it out, which is nice. Let's look at this one here. X squared minus x minus 12 over x squared minus 9. Which one do we want to factor first? Top or bottom? We can factor the bottom first, x squared minus 9. It is a difference of perfect squares, which is going to be x plus 3 and x minus 3. I think by this point we like the difference of perfect squares for factoring because they do factor nicely. And for the most part, we don't have to check a bunch of factors as long as we can see what the two perfect squares are. Now that also helps us on top. Now there is no greatest common factor. So we'll have our two sets of parentheses. Third term's negative, so our signs are opposite. Factors of x squared. X and x. Factors of 12. And 6, 3 and 4. 3 and 4, because we want one of the ones on top to be either x plus 3 or x minus 3, yes? So, the middle term on top, and this mainly works when the first term is just x and x, is the middle term positive or negative? So we would probably want the bigger number to be negative, yes? So let's try positive 3 and negative 4. X times negative 4 would be negative 4x. 3 times x is positive 3x, so plus 3x. Negative 4x plus 3x is negative x. That's it. So it is the middle term. Is there something in common on top and bottom? So x plus 3 and x plus 3 would simplify, leaving us with x minus 4 over x minus 3. Because again, since we have that minus, plus and minus, or minus between both the terms on top, and that minus between our terms on bottom, they are one expression. We can't just break them apart. I mean, we can, it just won't be helpful. Because if we did with addition, subtraction, the denominators have to be the same. So both denominators would be x minus 3. The top would be x and 4. We can't simplify from there. And I feel like that made it more complicated than simpler. It kind of defeats the purpose. Restrictions. X plus 3 and x minus 3 are two places where x cannot be 0. So with the x plus 3, we would subtract 3, telling us that if x is equal to negative 3, we'd have a division of 0. It can't be that. With our x minus 3, we can add 3. Telling us x cannot be 3 or negative 3. Questions on this so far? Are you ready for the next one? X plus 4 and x squared minus 16. If we look at the top, x plus 4, is there a greatest common factor between x and 4? No. What's the degree of the top? 1, because the degree is the biggest exponent attached to a variable, which is, that's as simplified as it gets. Because a way that we can check to see if something has a possibility of factoring, the degree has to be greater than 1. That's kind of one of the minimums for if we're factoring. So it could have been 2x plus 4. Greatest common factor 2, we can reduce that. Greatest common factor works if the degree is 1 or greater. But since the degree is 1, anything beyond greatest common factor, we can't do anything with it. So that's nice because the top is just x plus 4, because that is as simplified as it gets. On bottom, no greatest common factor, but x squared minus 16 is x plus 4, x minus 4. Do we have something in common on top and bottom? X plus 4 and x plus 4, yes? Well, the bottom, the only thing left is what? Now the question is, what's on top? 1. Because when we simplify, we're dividing. Because we have the x plus 4 divided by itself, yes? When we multiply and divide, the only way we can get a 0 is if one of those, the top or bottom is, we don't have any zeros here, so it's only going to reduce to 1. Anytime something simplifies out completely, it's going to simplify to 1. The only way we can get 0 is if 0 was on top. Or if I had like 4 minus 4 on top, then we'd have 0, it would cancel. But here, we can't actually have 4, even if we wanted to. Restrictions. So with x plus 4, we would subtract 4, telling us x cannot be negative 4. So x cannot be negative 4 or 4. Questions on this here? Questions on any of this so far? All right. I think this is the last simplifying expression before we start multiplying, yes? We'll do some multiplying today. Now, looking at this one here, x squared minus 2x minus 3 over x squared minus x minus 6. We don't have a difference of perfect squares. So we just got to pick top or bottom. Top. X squared, 2x, and 3 is their greatest common factor. Now, I would always look for greatest common factors because they're going to make things easier. Third term is negative, so the signs are opposite, plus and minus. Factors of x squared. X and x. Factors of 3 are 1 and, that's the only ones. Middle term is negative, so we'll probably want the bigger number, negative. We can check and make sure x times negative 3 is negative 3x. 1 times x is plus x, giving us negative 2x. That is indeed the middle term we wanted. So, those are our factors. On the bottom, x squared, x, and 6, there is no greatest common factor. So the signs are opposite, plus and minus. Our factors of x squared are x and x. Now the factors of 6 are 1 and 6 or 2 and 3. Well, we're going to need to either match up with x plus 1 or x minus 3, yes? So 1 and 6 or 2 and 3. Which one do we want to try first? 2 and 3. Now if we do 2 and 3, for something to match up, the 3 has to be negative. Because if it was x plus 3, nothing would match up, nothing would simplify. X times negative 3 would be negative 3x. 2 times x is going to be plus 2x. Negative 3x plus 2x is negative x. That is the middle term we wanted. So what's in common on top and bottom? X minus 3 and x minus 3. So all that's left is x plus 1 over x plus 2. restrictions. So the two places where x could be 0 is x plus 2 and x minus 3. So with x plus 2, we would subtract 2, telling us that x cannot be negative 2. With our x minus 3, we can add 3, telling us x cannot be 3. Questions on this here? Multiplying rational expressions. Let A, B, and C, let A, B, C, and D expressions with B and D different from 0. We just can't divide by 0. So if I have A over B times C over D, top with top, bottom with bottom, and then simplify if possible. So, and we have this here. Now let's look at this first one, because I think it's going to be easier to look at the first one than it is to try to break it apart in the example there. So find the product of these two. Well, we'll do two different ways to look at this. The first, we multiply numerator with numerator, denominator with denominator. We just multiply. What's 8 times 7? 56. Now x to the third times x to the fourth. When we multiply like bases, we add the exponents. So 3 plus 4 is 7. So telling us it's x to the 7th. Y times y to the third. So y to the first times y to the third. 1 plus 3 is 4. So y times y to the third is y to the fourth. Because we have y be multiplied by itself 4 times. We can do the same thing on bottom. 2 times 4 is 8. X, well, there is no other x terms on bottom, so it's just going to be x. And then we have y squared times y. It would be y to the third, y cubed. We feel comfortable getting to here. Okay. Is there stuff in common on top and bottom? X and Y? We'll go on and check the 56 and 8. Is there a number that goes into both 56 and 8? 8. If I remove 8 from 56, we divide it out, it becomes 7. If I factor an 8 out of 8, we get 1. Personally, I don't write the 1 yet. I want to see what happens to the rest of the terms. Because if x or y is still there on bottom, we don't necessarily have to write 1 times x or 1 times y or 1 times that term. So we'll leave it for now. X to the 7 over x to the first. Now when we multiplied like bases, we did what? We added the exponents, yes? So what would we do if we divide like bases? We would not add, but subtract. So 7 minus 1 is 6. Is it bigger on top or bottom? Top, so it stays on top. If it's bigger on bottom, it's going to stay on bottom. Because how many x's do we have being multiplied by themselves on top? 7, yes? How many do we have on bottom? So that means I can remove 1 x from the top and the, which means the 7 on top is going to go from 7 to, and the bottom one is going to be gone. So there's only 6 left on top, because we're just removing 1 from top and bottom. So y to the fourth over y to the third, 4 minus 3 is, and since it's bigger on top, it stays on top. So what's left on bottom? 1. Yeah, because we could write it over 1, or I just circle it. So this reduces to 7x to the 6 y. Because what we have on bottom is x times y. Really, yes? Well, the only way I can multiply two things and it be 0 is if one of them is. So either x is 0 or, so x, neither one of them can be 0, so x can't be 0 and y can't be 0. The only time we start getting different numbers is if we have addition subtraction. Then it starts throwing in different values. Questions on this here? All right, we ready to do this again? Because again, I want to show you a second way to do this. There are different ways we can tackle it. But I think it depends on person to person. Because if I look at the first rational expression, is there a common factor between 8 and 2? Yeah, 2. So we can reduce the 8 over 2 to 4 over 1. They have a common factor of 2, yes? X cubed over x have a common factor of x. So I can remove 1 from top and bottom, which tells me I have x squared over 1. Y over y squared, I can remove one of the y's, because 2 minus 1. It's just going to be y, and this y is on bottom. And the second set, 7 over 4, is just 7 over 4. There is no x on bottom, so the 4x's stay on top. And y to the third over y does then become y squared. So there's nothing saying that we had to just go straight to multiply. We could have simplified first and then multiplied. 4 times 7 is 28. X squared times x to the fourth is x to the sixth. We don't have any other y's on top, so it is y squared. On bottom, we have 4y. 28 divided by 4 is 7. No other x's, so it's just x to the sixth. Y squared over y is same thing. Yeah. So again, it's whichever way you see nicer, but also we could have canceled the 4's out at that point, because again, we're multiplying. So there are different ways to go about simplifying. I would say, again, whichever way you see first, or feel most comfortable with, go with it. See where we're at. Oh yeah, let's do this one here. Because, yeah, we can multiply this out. 6 times 9, 54. X squared times x to the fifth, x to the seventh, because we have 2 plus 5 gives us 7. Y times y squared is y to the third. Questions on how we got the numerator, the top of that fraction? The bottom, 3 times 2, 6. X, well, there's only one x on bottom of either one, so it's just going to be x. Y cubed times y, y to the fourth. Questions on this here? Now 56 or 54 over 6, both have a common factor of 6. So the 54 is going to reduce to 9. The 6 is going to reduce to 1. X to the seventh over x. 7 minus 1 is, and since it's bigger on top, it stays on top. Y to the fourth, or y to the third over y to the fourth. 4 minus 3 is, since it's bigger on bottom, it stays on bottom. Because I spaced out for a second when I was writing. No, it is just y. For some reason, I just wrote 4. No real reason behind it. It's just y. And if we want to list the restrictions, X cannot be 0, Y. For this here, yes, because we're multiplying together. Addition and subtraction is when we really start getting X minus 3, Y plus 2 is where we start getting different values. So that's going to cause it to be 0. Since they're just multiplying. Because 6, if we plug in 0, for X it doesn't matter what Y is, I'll say it's 3. Well, 6 times 0 is 0, no matter what 3 to the 4th is. Well, 81, it's still going to be 0. Same thing with Y. Questions on this here? So